various drying oils. Okay. Now, the processing and modification of linseed oil, that is the topic of our discussion today as regards linseed oil. Okay, there are several ways of refining linseed oil. One of the ways is the simplest. Heat at 275, 250 to 275 degrees centigrade. There will be a break material which will come out. Break material will come out on heating. It is a miscellaneous siliceous material. So this is nothing but lecithin. This material is lecithin. It is filtered. It is filtered, and the now the oil which is you are getting is a better oil for paints, because lecithin may appear with the homogeneity of the material. So simplest way of processing linseed oil is to heat it at a higher temperature for say half an hour or something, and a break material will come onto the surface. This break material is separated. That is one way of getting a useful vehicle for paint. The other is known as alkali refining. Oil is heated and treated with NaOH. A little excess 10 to 20% is taken, and once the neutralization is over, it is thoroughly washed with water. And then subjected to drying by vacuum or by heating. That is how we get alkali refined oil. There is third way of modifying linseed oil, that is acid refining. This is particularly practiced in case of linseed only. Remember, acid refining. Lead-lined vessel and fairly concentrated sulfuric is added in a fine stream or spray, about 1% of the weight of the oil. Means on the surface of the oil, what you are doing, 1% sulfuric acid is sprayed by means of a fine stream or spray gun. That is known as acid refined linseed oil. Now refer to table number 1. Please go to your WhatsApp and see your table number 1. See table number 1. Characteristics of raw and modified linseed oil. Now you have to remember one thing, that there is little difference between boiled, stand and blown oil. That comparison we will take up later on, but just try to have a comparative idea of all these forms of linseed oil. First is specific gravity. If you look at the figures, you will find that when you process the oil to boiled, stand or blown oil, there is slight increase in specific gravity. Just see, move on the right hand side of the table, the raw acid refined blown oil has the highest 0.96 to 1 specific gravity. Okay. Then viscosity. Viscosity of raw oil is very less, 40 centipies. Acid refined more or less the same, alkali refined same, But boiled oil has a somewhat higher viscosity, 0.8 to 1.2 poise, slightly higher viscosity in boiled oil. Okay. Then in Strand Oil again, the viscosity is more than 3 poise, and you can get very high viscosities of Strand Oil by heating for a longer time. Normally we take 6 to 8 hours for heating, but you can go for 10 to 12 hours and have 20 poise or more viscosity. If you are making a printing ink or different utilizations are there, so based on them, you can get a viscosity of 3 poise or more for Strand Oil. Okay. Then the third one is blown oil. Blown oil, about 3 poise viscosity is there, and here also you can increase the viscosity. If you look at the third point, that is refractive index, it is slightly higher than normal oils for Strand Oil. Then acid value. Normal raw oil has a acid value of 1 to 3, just to note down. While acid refined has slightly higher acid value, 7 to 8. Why it is so? Because perhaps the oil has undergone hydrolysis and some fatty acids are released, because treatment with acid is stronger, and therefore there will be some breakdown of the triglyceride to give free fatty acids, and therefore the acid value is 7 to 8. Then alkali refined oil, it has got a very less acid value, 0 to 0.5. The boiled oil has a acid value of 2 to 4, and Strand Oil again has a higher acid value. The reason is you are heating it at a very high temperature. In case of Strand Oil, the heating temperature is very high, and therefore you get a slightly higher acid value of 4 to 12. And for blown oil, it is 4 to 6. Normally speaking, when you heat the oil at a very high temperature, then there will be some breakdown, or if you treat it with acid, then also there will be a breakdown of triglyceride, and you will get slightly higher acid value. Then iodine value. Iodine value of raw oil is 175 to 185. But after heating, some of the double bonds are lost in oxidation or polymerization, and therefore in boiled oil, the iodine value is 160 to 170. In Strand Oil, as the temperature of reaction is very, very high, say 270 degrees centigrade, therefore the iodine value is 130 to 50, means more double bonds are utilized in the process of oxidation. What the lower iodine value indicates, that double bonds have been engaged or utilized. हाँ बोलो. आलो 1 मिनट. हाँ. So boiled oil, Strand Oil, blown oil. Boiled oil has a iodine value of 162 with some reduction in iodine value. Strand Oil 130 to 150, more reduction in iodine value. And blown oil 100 to 140, still lower. That is the iodine value of various modified oils. Now, last but not the least is drying time. If you apply a film of raw linseed oil or acid refined oil or alkali refined oil, it will take 4 days to dry. It will take 4 days to dry. While boiled oil will take 16 to 24 hours, almost 1 to 2 days, while Strand Oil will take 24 to 36 hours. A more thicker material, it takes a slightly longer time than boiled oil, but better than linseed oil. Linseed takes 4 days, while this Strand Oil takes 24 to 36 hours, and blown oil 24 to 36 hours. This is a comparison of the physico-chemical properties of boiled, stand and blown oil. But now let me, you can refer to table number 2 now. Go to table number 2. In table number 2, what in fact in our laboratory about 10 years earlier, we were making all these oils in our laboratory. Boiled oil, blown oil, stand oil. These were the regular experiments which were given for our BSc Tech students. Very simple. In a beaker, say 2-liter beaker or a little 5-liter larger vessel, we take the oil, pass oxygen through it. There is an oxygen cylinder or air passing equipment is there. So pass air through it, raise the temperature, stir it and maintain the temperature. That is important. The temperature stirring may not be necessary, as bubbling of air will give agitation automatically. So just control the temperature by a thermometer. If I talk about boiled, blown and stand oil, let me first explain you that what is the difference between the three. Boiled, blown and stand oil. Boiled oil is normally prepared at 137 degrees centigrade. Lowest temperature is used. 137 degrees centigrade. Here we make use of dryers, zirconium and manganese dryers. Pass air till you get the desired viscosity, that is boiled oil. By using manganese dryer, you get a slightly darker color. So what we do, we replace manganese by cobalt or some other dryer and we get pale boiled oil. Pale boiled oil. Pale boiled oil is lighter in color and it is added to various oleoresinous paints to improve flow and brushing properties. You know that any paint needs a good flow property. You should be able to brush easily the paint, then it will be applied. So these two properties, if you add pale boiled oil, say 4 to 5%, there will be remarkable improvement in flow and brushability properties of the paint. This is also used in undercoats along with alkyd. Small amount of pale boiled oil is added that will improve flow, leveling, brushing and other characteristics of the paint. So smaller boiled oil today is used as a smaller additive to the paint. Okay. Now what is this blown oil? In blown oil, we blow air through the oil. The temperature is maintained between 125 to 135 degrees centigrade. Temperature in blown oil is maintained at 125 to 135 degrees centigrade. And here we do not make use of dryer. This is most important thing. No dryers are used. In boiled oil, dryers are used. In blown oil, no dryers are used. And you can get the viscosity, whatever you need, by heating for longer times. This blown oil gives a good initial gloss. Remember it. चमक आना चाहिए ना पेंट में, तो थोड़ा सा ब्लोन ऑयल डाला आपने, तो ब्लोन ऑयल से क्या होगा, थोड़ा पेंट में इनिशियली ग्लॉस बढ़ेगा. बट दिस ग्लॉस इज नॉट परमानेंट. आफ्टर सम टाइम the gloss is eliminated. Gloss retention is poor. Initial gloss is good, but gloss retention is poor by using blown oil. Last but not the least is Strand Oil. In Strand Oil, we keep a very, very high temperature. How much? 280 to 300 degrees centigrade. Very high temperature. No dryers are used. Just by heating, you prepare Strand Oil. If you go on heating, suppose you heat this oil for 6 hours, you get a viscosity of say 2-3 points. If you go for 8 hours, 10 hours, you can get any viscosity ranging from 20 to 50 points. Means depending on time of heating, you can improve or get better viscosities. That is Strand Oil. This is used, as far as the use is concerned, this is used in varnishes, which are cooked or cold cut varnishes are also. Cold cut means just mix with shellac or rosin, that is known as cold cut varnish. And cooked varnish means this Strand Oil is mixed with rosin or something and make the varnish out of it. So mainly Strand Oil is used in varnishes and printing inks. Where it is used? Varnishes and printing inks. Carbon black जो अपना newspaper ink रहता है ना, newspaper ink or similarly letterpress ink is there, which is there in books. The raw material mainly is Strand Oil. Okay. Now, how the three differ in linkages? Means polymerization gives linkages, is it not? Polymerization means from monomer to dimer, dimer to trimer, and more the polymerization, degree of polymerization, higher the viscosity. So what kind of polymerization is there? So broadly speaking, in blown oil, COOC or COC linkage is more prominent. Remember, direct carbon to carbon linkage here is not there because you are not using any dryer, and oxygen absorption is the main way in which the thickening of the oil is taking place. It is brownish yellow in color. This is blown oil. In Strand Oil, the situation is different. Carbon-carbon bond is only formed when the temperature is very high. But out of all these bonds, carbon-carbon is the most stable bond. Remember, durability, resistance to acid, resistance to alkalis, all these properties are better managed in Strand Oil. And the main linking is direct carbon to carbon because we are just heating it. Even in the absence of dryers or even air is not blown into it, and you can achieve any viscosity between 3 to 200 points. In boiled oil, as we are using dryers, linking through oxygen is also there and small amount of carbon to carbon linkage is also there because dryers have been used. So this table will try to revise and try to understand the difference between boiled oil, blown oil and Strand Oil. एक एक पॉइंट को थोड़ा नोट करो, आपको ये समझ में आना चाहिए because when I ask the questions in the examination, the students are not able to exactly discriminate between the three oils. देखो, boiled oil and blown oil, they are prepared at a lower temperature, remember. 125 to 136 degrees centigrade. Means cooking temperature in case of boiled oil, blown oil is how much? 137 or 125 to 135 degrees centigrade. While in Strand Oil, the temperature is very, very high. Comparatively, in Strand Oil, the temperature is very, very high. In boiled oil or blown oil, we pass air through the oil. So oxidative polymerization is more. While in Strand Oil, either we apply vacuum or we do not add dryers, neither we add oxygen, just heat the oil. So carbon-carbon direct bonding is promoted, because at this higher temperature, there will be formation of conjugated double bonds. They will react with each other, and mainly carbon-carbon link is most important in Strand Oil. And out of all the linkages which are given here, carbon-carbon is the most stable bond. Therefore, durability, resistance to weak acid, resistance to weak alkalis, that is better in case of Strand Oil. I think you understand now what is the difference between boiled, blown and Strand Oil. Commercial uses are also different. Pale boiled oil is used in paints to improve flow and brushing property. When the paint doesn't have, some of the alkyds are very thick and they do not give a desired flow or brushability properties to the paint. So addition of small amount of pale boiled oil will give this property. And blown oil is used where a high initial gloss is essential. Initially, the gloss is very high, but with time, the gloss goes on decreasing. And gloss retention by using blown oil is poor. Means gloss initially will be there, but it will fade out with time. Strand oil is used mainly in varnishes. फर्नीचर वार्निश रहते ना आपने, स्टैंड ऑयल को रोजिन के साथ मिक्स करो, add with some other alkyd resin, we make a varnish and can be used as a transparent polish. Transparent polish, that is varnish. And you can also use Strand Oil in making newspapering or say letter pressing. Various inks are also based on Strand Oil. So that is known as Strand Oil. There is one varnish which is known as Litho Varnishes. Write down Litho, Litho Varnishes. Litho Varnishes are very high in viscosity. They are prepared in open pot with high temperature to attain higher viscosity. There is one more preparation which I must mention, that is enamel oils. What is this enamel oil? E-N-A-M-E-L, enamel oils. Now you may ask me a question that why paints are known as synthetic enamel. Anybody knows why a paint is known as synthetic enamel? एनेमल वर्ड कहाँ से आया है, ये सोच सकते हो आप? कैन यू थिंक अबाउट इट? यश?
No, sir.
This enamel word has come from enameling or pottery industry. In pottery industry, you get very bright appearance, is it not? Pottery बनाते हैं तो उस पे ब्लू फूल निकालते हैं या डिजाइन निकालते हैं, तो क्या होता है, एकदम ब्राइट कलर आता है उसको. That is known as enamel. So here that word is coming from that side, and it tells you that you are preparing something which is brilliant in appearance, highly glossy and superior in quality. Therefore we call it as synthetic enamel. This enamel oil is prepared by mixing 1 part of tung oil, enamel oil, you can write down, enamel oil, 1 part of tung oil is mixed with 3 parts of linseed oil and cook it at slightly lower temperature than Strand Oil, because tung oil polymerizes very fast. Therefore, instead of 280 to 230 degrees, जरा चिल्ली घेशील हो एक मिनिट आलो. So here the temperature is slightly lower than Strand Oil. It is around 250 degrees or 230 to 250 degrees centigrade. But why this mixture is used? Because tung oil is very fast drying. Try to understand this point. Tung oil is costlier. It is only available in China and few countries. Therefore, it is a costly oil. So 1 part of tung oil and 3 parts of linseed oil. Linseed oil is also dries faster. But when combination is made, the two will move forward in drying. Not only they will move forward in drying, but the films are very hard. When the mix are better, always remember, tung oil itself is very fast drying, it's okay. But when we mix 1 part of tung oil and 3 parts of linseed oil, the combination itself attains maximum or optima of all the properties. Here, the films are harder and more specifically, they have good water and alkali resistance. Remember, they have good water and alkali resistance. Now you can turn to page 3. See page 3 on your WhatsApp message. Have you opened?
Yes, sir.
Here I am giving you a method of modifying castor oil. If you look at the composition of castor oil is resinolic acid. I have written the structure of resinolic acid. 9 double bond and hydroxy group at 12 position. That is the structure of resinolic acid. And about 80 to 85% of castor oil is composed of this resinolic acid. This resinolic acid, because of the OH group, castor oil behaves differently than other oils. Remember that castor oil is little soluble in alcohol, while all other vegetable oils are insoluble in alcohol. But castor oil is slightly soluble in alcohol. Why? Because there is a OH group in the structure. And extracted castor oil, commercial castor oil, is quite good in color and appearance. Its viscosity is also very good. So it is modified and converted into dehydrated castor oil. It is converted to dehydrated castor oil. The dehydration is done at 260 to 280 degrees centigrade in presence of a catalyst, which is nothing but a mixture of sodium sulfate, NaHSO4 and NaHSO3, sodium bisulfite and sodium bisulfate. This combination will hasten the process of dehydration of castor oil. When you start heating, the first stage is removal of this OH group by dehydration. So initially the viscosity, if we plot the viscosity of castor oil will first go down for 3 hours or so. And if you consistently heat it further, then it will pick up higher viscosity. This is known as DCO Strand Oil. This is known as DCO Strand Oil. Now look at the structure of this resinolic acid on page 3. Look into the structure. Here there is one OH group at position 12. थोड़ा उस पे पेन रख के देखो उसको. 9, 10 is a double bond. 11 on position 12 there is one OH group. Okay. So when you heat this oil, in presence of catalyst at a higher temperature, this OH can extract a hydrogen from right, or it can also extract a hydrogen from left. OH, there are hydrogens available at position 11 as well as position 13. So OH can remove hydrogen from position 11. It can also remove hydrogen from position 13. Both possibilities do exist. That is known as dehydration of castor oil. If you remove hydrogen from position 12, then what you get is 9,11 octadecade dinoic acid. I have written down the structure. Here you have a conjugated double bond system, CH double bond CH, CH double bond CH, and so on. So 9,11 octadecade dinoic acid, this is a fatty acid or structure in which there is a conjugated double bond. The other possibility is hydrogen may be extracted from left hand side. Then you get 9,12 octadecade dinoic acid. Here the conjugated double bonds are not there, they are non-conjugated double bonds. Now you may ask a question that how much this 9,11 and how much this 9,12? Lot of investigation has been done in this reference, and depending on condition, about 1/3 is conjugated and 2/3 is non-conjugated. The effort of a chemist is to get maximum amount of 9,11. Why? Because 9,11 has conjugated double bond. It will dry faster. Compared to 9,12, 9,11 will dry faster. This DCO, you can raise the temperature and get different viscosities of the Strand Oil. Initially, the castor oil viscosity goes down in 3 hours, and then it shows a continuous increase, and after some time it shows a very trend of viscosity. DCO is a good starting oil for paint. Why? Because color is good, yellowing is not there, color is fair, yellowing is not there, but there is one defect with DCO, that is after tack. आफ्टर टैग ऐसा उंगली आप अंगूठे से प्रेस करेंगे तो प्रेस करने के बाद थोड़ा टैकी लगता है, गीला लगता है. दैट इज नोन एज आफ्टर टैक प्रॉपर्टी. So that after tack property is there in DCO. That after tack property to some extent is useful in printing inks, but not in paints. So what we do, as far as paints are concerned, there are a type of finishes which are known as baking finishes. Baking finishes or stoving paints. In stoving paints, this DCO is used very frequently. Why? Because on heating, it doesn't undergo yellowing. The color remains stable, white or transparent. If it is linseed oil, it will have a tendency to convert into yellow on heating. While DCO is such an item which will polymerize, make a harder film, but it will not change in color. And this DCO product gives good water and alkali resistance also. Fair resistance to water, acids and alkali is given by dehydrated castor oil. Long back, I visited Hyderabad and there were several companies which were making only dehydrated castor oil for paint industry. This dehydrated castor oil in tons and tons from Hyderabad was supplied to paint factories like Asian or Goodla's Nerolac. I came in contact with some small scale industries which were making DCO only. DCO in huge tonnage, every day 5 tons, 10 tons, etc. Even today, I am not that much in contact with paints, but yet this is a very good starting material from paint, dehydrated castor oil. Let us revise this dehydrated castor oil. What is happening? That main component is resinolic acid. What is resinolic acid? 9 double bond, 1 OH group at position 12. On severe heating and presence of a catalyst, what happens that OH extracts hydrogen either from the right or from the left. If it extracts hydrogen from the right, we get conjugated system. If we extract from left, we get non-conjugated system. This conjugated has been estimated to be about 1/3 of the total conversion which is taking place. And because of these conjugated double bonds, it has better drying, better resistance characteristics than linseed oil to some extent. Not as good as tung oil, but better than linseed oil. DCO can be placed in between linseed and tung oil. This finishes with your topic on dehydrated castor oil. So I think about drying oils, I have given you a good amount of information. Now you have a chance to ask me some questions.
सर ते फिजियोकेमिकल प्रॉपर्टीज मध्ये आयव्ही का जास्त होते बॉइल्ड ऑइल आणि
कशामध्ये
फर्स्ट पेज फर्स्ट पिक मध्ये जो टेबल आहे
ना जो कॉलम आहे तो रॉ लिन्सीड ऑइल आहे त्याची आयोडीन व्हॅल्यू तर जास्तच राहणार आहे ओरिजिनल आहे मग त्याला आपण प्रोसेस करतोय त्याला हीट करतोय त्याच्यामध्ये ऑक्सिजन इंड्यूस करतोय आणि त्याच्यात पॉलिमरायझेशन तर पॉलिमरायझेशन मध्ये काय होतं की डबल बॉन्ड जे आहे ते कंझ्युम होत जातात डिसल्टर रिएक्शन अँड ॲज द डबल बॉन्ड्स आर कंझ्युम्ड इन अ रिएक्शन द आयोडीन व्हॅल्यू विल गो डाऊन इन फॅक्ट iodine value is a mirror or reflection of the extent of polymerization to some extent. The more polymerization, the less the iodine value, the less polymerization, the higher the iodine. Means IV is an index of measuring either oxidative or thermal polymerization. Therefore, it has been mentioned, just see, the iodine value of Strand Oil is very low, 130 to 150. What does it mean? That from 170 to 130, whatever double bonds are there, they have been utilized in the process of polymerization. Similarly, this is true for blown oil also. Here also, the double bonds have been utilized or consumed in the process of polymerization. Anything else?
सर आणि तुम्ही डबल बॉन्ड्स बद्दल बोलले होते काहीतरी त्याच्यात
हे पहा आयव्ही म्हणजे काय आहे माहिती आहे का तुला आयव्ही काय
सॅच्युरेशन
IV indicates unsaturation. Higher the unsaturation, more the lower the unsaturation, lower the IV. Do you remember it?
Yes,
IV, definition of IV. Huh? What
yes,
it indicates? Higher the iodine value, more the unsaturation, lower the iodine value, lower the unsaturation. So in the processing, what we are doing, Either we add oxygen or heat it, convert it into a conjugated form, and utilize double bonds in the process of polymerization. Utilize double bonds in the process of polymerization. And once the double bonds are utilized, the iodine value will go down.
Mm.
This you can observe in blown or Strand Oil. About original is 180 say, and then it is 130 to 150. That means where the remaining double bonds have gone, they have gone in the process of polymerization. And therefore it is thick also comparatively. Is it not?
Yes.
Any other point?
Sir, the tacking property in
हं?
dehydrated castor oil.
हां,
सर
पुन्हा
त्याबद्दल थोडं
समजवतो.
हो सर
हां,
थोडं
ठीक आहे,
एक्सप्लेनेशन
ठीक आहे.
हवं.
Castor oil main ingredient is resinolic acid. Go to page number 3.
येस सर.
The main fatty acid is resinolic acid, 80 to 85% present in castor oil. And this resinolic acid gives different properties to castor oil compared to all other oils. Castor oil is soluble in alcohol, while all other oils are insoluble in alcohol. Why? Because there is a OH group present in it. It is quite viscous compared to other oils. If we have used castor oil, hello, बरं. हां हां बरोबर. ठीक आहे, पण कुठेतरी ऍडमिशन झाली ना, हे माझ्या दृष्टीने महत्वाचं आहे. हां, हो हो हो. चला चला, थँक्यू. पण काही असो, आपलं काम झालं. माझं सध्यात महत्वाचा इश्यू हा होता की आपलं काम झालं पाहिजे. हां, हो हो, ओके ओके. हो. So this resinolic acid gives different properties to the castor oil, is it not? So
Yes,
what
sir.
we are doing, we are subjecting it to dehydration in presence of a catalyst. Catalyst is either sodium bisulfate or bisulfite or combination. So by this combination and high temperature, there is a tendency in the molecule to extract hydrogen either from right or from the left. If I extract a hydrogen from right, then I get 911 conjugated double bond fatty acid. If I extract from left, I get non-conjugated 912 octadecadenoic acid. Now, how much is the ratio? About 1/3 is this conjugated and 2/3 is non-conjugated. But yet, this 1/3 conjugated helps in quicker drying and pen properties of dehydrated castor oil. Whatever good properties in dehydrated castor oil which we are getting are mainly because of the presence of 911 octadecadenoic acid, because there are conjugated double bonds which respond fairly better for oxidative or thermal polymerization. If you try to grade it, then tung oil is the best, then comes DCO and then linseed. But DCO has a tack problem. Linseed oil doesn't have a tack problem. If you try to study the properties, DCO gives good water resistance, good alkali resistance and all properties, but it has got an after tack. So for that reason, you can make good stowing paints out of it. Okay? And at least one more question. Somebody.
सर इनॅमल ऑइल का काय यूज होता सर?
काय काय Once again.
इनॅमल ऑइल कुठे यूज होतं सर? इनॅमल ऑइल कुठे यूज होतं?
Enamel oil is used in fast drying paints. Enamel oil is a combination of very fast drying linseed tongue oil and a little slow drying linseed oil. So combination gives a faster drying property. So 1,3 will be a better product than linseed oil alone. In respect, not only in respect of drying, but in respect of water resistance, in respect of alkali resistance, in this reference to resistance to dilute acid or hardness, in all references, enamel oil is a better starting material. But for that, you should be able to get tongue oil, because tongue oil is a very costly oil and it is not always available. That is the difficulty. In India, there is practically no production of tongue oil. Some effort is required to make or to cultivate tongue oil in India. It will have a good market, I would say.
सर म्हणजे डीसीओ जिथे आपण यूज करतो म्हणजे जे ऍप्लिकेशन्स डीसीओचे आहेत त्याच म्हणजे एनएमएल ऑइल इज फार बेटर दॅन इट. तर मग आपण डीसीओ जे आहे जसं त्याला टॅक प्रॉब्लेम आहे तर म्हणजे एनएमएल ऑइल त्याला रिप्लेस करतं का दरवेळेला?
नाही, असं नाही आहे. एनेमल ऑइल खूप महाग पडेल. कॅस्टर ऑइल आपलं ओरिजिनल रॉ मटेरियल आहे आणि डीसीओ थोडं आणि लिन्सीड घेतलं तरी प्रॉपर्टीज मिळतात. स्टँड लिन्सीड ऑइल, समजा एक स्टँड ऑइल बनवलं ज्याच्यामध्ये डीसीओ 50% आहे आणि लिन्सीड 50% आहे आणि त्याच्यापासून स्टँड ऑइल बनवलं, इट विल ऑल्सो वर्क. क्वेश्चन इज टंग ऑइल इज एन इम्पोर्टेड ऑइल and it is very costly. So buying a material from outside with higher cost, it is better to blend oils which are available with us. Linseed is available with us, DCO is available with us. And after tag problem, if DCO proportion is less, proportionately the tendency will be less. And huge tonnage of stoving paints is made. Today, whatever paint you apply on furnitures, on various electrical items, they are all stoving paints. फैन के ब्लेड्स रहते, उसके ऊपर भी स्टोविंग पेंट लगता है. Stoving paint means coat the material, heat the surface for some time and take it out. Normally for even a enamel paint you require 3 hours for drying, but in baking finishes just half an hour is sufficient. You bake the material for 150 degrees centigrade, whether it is fan blade or cycle spare parts or furniture spare, bake it in a oven at 150 degrees centigrade. Within 15 minutes to half hour you can take out. In fact, all the things are utilized depending on availability, economics and technology. Three things decide what you are going to do. Availability is one factor. If I don't have tongue oil, whatever better it is, I cannot do anything about it. Availability is one thing. Technology is the other thing. You should know that how to utilize that material properly. Then only you can advocate it. As a basic science, I have to explain the characteristics and properties of all the raw materials which are used commercially. हाँ हेलो बोला. हाँ हेलो 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 हेलो. आवाज का नहीं है. बाबर वैद्यांचा फोन. So I think that is sufficient for today. What is the status of COVID in your area? I don't know, but here it is very severe. There were some deaths reported in Trimurti Nagar. And nobody, I was having a phone call with somebody in which the patients are moving from hospital to hospital to get a bed. Very worst position in Nagpur. Let us hope that it will improve. अपने इतने बड़े बड़े नेता हैं और फिर भी लोगों को बेड नहीं मिल रहा है. That is the reality. Huh? People are moving. In fact, मेरे एक पहचान वाले हैं वो in an ambulance they are moving from one hospital to another. The patient is serious with a COVID score of 15 and he is not getting a place anywhere. This is the means we are going from a very, very crucial position today. Anyhow, so we will meet again on next Friday. Okay?
Yes, sir.
Just see your timetable, whether it is viable or not. Next Friday.
Yes, sir. It is viable.
If it is viable, I think you can tell me also that having 3 lectures in sequence is good or bad. I think it is good. Continuity
Yes,
is
sir.
maintained.
Yes, sir.
Yes.
Because if I take one lecture today, after 4 days, you will miss the continuity. So to avoid that, let us repeat this Friday, Saturday, Sunday. Huh? Best
sir.
wishes for Gudi Padwa. Huh?
Thank you, sir. Thank you so much.
लोक फायनल
Same
इयर
to you,
मध्ये
sir.
असा फायनल इयर मध्ये हा जरा गुडी बिडी चढवावर.
Yes, sir.
And I hope that all of you will be placed nicely in coming year, and you will have a very bright and pleasant future. Thank you.
Thank you, sir.
We
Thank you so
will
much.
again on
Thank you, sir.
Friday. Hmm?
Yes, sir.